Hello, welcome to module number 2, where we'll be discussing about the possibilities of improvement in the protocol that you are currently following or you are planning to follow. This is the module where we'll be discussing about how we can be of help to you to make your life easy. Let's, let's have a quick look on what are the possibilities. When you have an idea and you are excited about seeing whether it works or not, you read through the papers and do a lot of hard work, maybe a couple of weeks of hardcore research, and then you come up with a sample which also takes a couple of weeks or months sometimes, and then you do a very intense sample prep, and finally you get to the end point of having a beautiful sample which can give you the image that you are looking for. You come to the microscope and then the life starts becoming more complicated because the microscope software is kind of complex and the microscope has so many buttons and so many options, and somebody has told you that microscope objective costs at least $10,000 and sometimes it can be $25,000. You don't want to bash the microscope, you do not want to touch the wrong button. Oh my god. And okay. And then after having a scary journey, you still managed to overcome your fear, and then when you were acquiring the image, then you found out that you were expecting to get a non-colocalized image and you're getting a colocalized image because potentially the parameters in the microscope equation are wrong, or you were expecting a bright image and suddenly you see a dim image, and now you are thinking, is my experiment working, or is it because my during the sample prep I put less antibody, or my mouse is expressing less protein, or did I do the wrong research? You are questioning the entire process, and then you find out that you used the wrong microscope objective or you used the wrong oil, right? So a lot of those small parameters are always there, and that's how you can convert this microscope from a devil into a friend if you understand the microscope beautifully and understand the entire process. So we can be of help in the process of sample prep. We can recommend you which color to use so that you do not end up in a situation like this. Also, we can be of help in the image acquisition process so that you can get the best image that you are looking for. We can help you with the microscope selection so that you can get the image which is the best one that you can acquire from all the microscopes that are available. And lastly, the data analysis part. Sometimes it is uh, useful to do the manual analysis, but most of the time it's always a good idea to automate the entire process so that there is no manual error coming in, and also it can be replicated by somebody else in some other part of the world. So here's a case study. Basically, it's my story, personal story, which I was doing my PhD, and how during the journey I realized why this is very important to understand the microscope as well as the various parameters. So in this paper, what we were doing was to measure the amount of chloride inside the endosomes in living cells. So Sonali was the one who started this project, and she has a very high ambition and wanted to measure the chloride here and in the lysosome for the first time, and she actually managed to do it. Uh, in order to do that, all you have to do is to send the sensor inside the compartment, and once the image is acquired like this, if you draw a line profile, what you see is that the intensities across the cell of the background is non-homogeneous, and in order to get these numbers here, you have to take a ratio of the green channel to the red channel. Now if you want to do that with this kind of a background, you will be having a lot of errors. So Sonali came up with the idea that we can do a stringent background subtraction by drawing regions around the endosome. This blue one is the endosomes, and the white circles here are basically the background area. She used to draw these ROIs manually, and then measure the intensities in each of these, take an average and subtract that from the image, and then whatever intensity comes from the image of one endosome in one channel, put that in the Excel sheet, and same way do for the other channel, and do that for over hundreds of endosomes like this in triplicate. So imagine the amount of hard work she did. I have a huge salute to her. If I were given this project, I couldn't have done that. After all of that hard work, she was able to manage to get a good signal to noise and was able to get this result, and it was the first measure of uh, chloride in the lysosomes of a living cell. Later on, we figured out that why the signal to noise was so bad. The original paper from where the dye was reported in, they were using Alexa 488 typical kind of a microscope setting for acquiring the image, even though the spectrum was not similar to Alexa 488. Potentially they were using it because that was the only filter set that they had, and we didn't check, and we ended up having molecules to be excited in a very inefficient way, and that's why the signal to noise was very bad. Later on, once we figured that out, our lab people, we reconfigured the microscope and we started using a different set of excitation. We could have also used the 667 nanometer excitation, but it's too much in the UV range, so we chose to use the CFP kind of excitation. And once we did that, my lab mates were not just able to improve the signal to noise by 3 to 4 times, but also were able to take the sensor inside a living organism and do measurements of chloride in the compartments of a living cell inside a living organism like C. elegans, and use it for diagnosing different kinds of disease states and genetic backgrounds. So a simple change in the position of the spectrum could do so much of effect. And like I said before, I am not such a hardworking person. I'm kind of lazy. I want to find ways by which you can always reduce the amount of human effort that is needed. So here's an example what I did. So this is the original cell image, and doing background subtraction manually against each endosome was too much of pain for me. So I started looking for ways by which you can automate the process, and I found that if we draw a circle here and do the background subtraction, it will not do the job because the background here is different from background here. So if there's a method in the ImageJ which I discovered later on, is called rolling ball background subtraction, which can adaptively subtract the background in such a way that it makes all the background zero and leaves only the endosome intensities like this. And further, there's still some noise left there. If you use some kind of a band pass filter to eliminate this high frequency noise, then you get really smooth intensity patterns which can be again automated further, that you can select the particles, do hundreds of endosomes at one go. This way the entire process of 8 hours of hardcore expert level image processing manually was reduced to a few clicks and 15 minutes of work. So this is how I was able to reduce my human labor and get a similar kind of a result reproducibly for my experiments. So I'm not saying that I'm a big shot. All I say is that I'm a lazy person, but I think crazy. So same way, I also encourage you to do the same and try to figure out ways by which you can reduce the manual labor and learn through the mistakes like I did. We really had to struggle a lot, but we eventually learned through the experiments and struggles that what to do and what not to do, and that's the whole point of research. Because if research was to be done in one go, PhDs won't take 5 years, it will take only 6 months, right? So with that, we come to the end of the module number 2 of workflow overview and possibilities of improvement. And if you are thinking who is this person here, that's me. just to show you who am I, and you can always reach out to me, and so that we can help you with the imaging needs. With that, these are the contact details. This is my email address, and this is the Imaging Core email ID. So feel free to reach out to us, like I said, anytime. And with that, happy imaging.